Alright, so moving on to 5.2, verifying trig identities. So from 5.1, we cover a lot of things. There were a video for each of these listed concepts, topics, rewrite using only sine and cosine, simplify by factoring, simplify by combining fraction, and then the last one was simplify by eliminating fraction. So as we practice one or two examples for each topic, and yes, it was long, but you see how these four are connected. These four go hand in hand when we're verifying identities. Now for 5.1, we practice using each of these four concepts, and then two of them, three of them, or even four of them were all together in some example that we did in class. Now you will see them again for 5.2, verifying identities. Now you can choose any of them, or you can use a combination. Now what mostly helps is rewriting using sine and cosine. If you're unsure or if you're stuck, the best way is using sine and cosine. If you're unsure how to combine with fractions, eliminate with fractions, or factor, always convert to sine and cosine. As long as you convert into the basics, you should be fine. Now, what was different from 5.1 and 5.2? 5.1, when we're using these four topics, you were unsure in what directions to go, and sometimes you feel like you're stuck or you stop. You just don't know what else to do. In 5.2, when we're verifying identities, we're verifying that both sides are equal. So what it means is that given a trig expression, just like in 5.2, now in 5.1, that's what I mean, given a trig expression. So if you have one just like in 5.1 and you're simplifying, but in 5.2 you actually have something that it should equal to. So you have a sense of directions on where to go towards. So 5.2 is using these four concepts and having a trig expression equal to a simplified trig expression. So now you have an answer that you want to go to. You have an answer where you're going to simplify the expression. So now you have a better sense of direction. So 5.2 is a bit easier, but it's still a lot of work. Alright, in our first example, we have cosecant square x minus 1 over cosecant square x equal to cosine square x. Now you know what your expression should equal to. Now when it comes to verifying trigonometric identities, this one we could just cover verifying a trig identity. Basically, we're going to work on or as they said, work on the complex side, the complicated side. So we're going to work on the left side. Now, here I notice we have a cosecant square x with a 1. I could use the Pythagorean identity. And the only one that uses cosecant square x with the 1 is cotangent square x plus 1 equal cosecant square x. Now, if I want to get the 1 to be with cosecant square x, minus 1, minus 1. So cotangent square x equal cosecant square x minus 1, which is exactly the same as the numerator. So I'm going to rewrite this fraction as, instead of cosecant square x minus 1, it will be cotangent square x over cosecant square x. I'm not going to worry about this. This is what I know it should equal to. Next, I'm going to factor out the cotangent square x. So what I'm going to do is, when we're here, factor out cotangent square x. So what I mean by factor out is I'm going to pull away from the numerator. Now, if I were to ask you what would be the factor, it would be, what would be the factor for cotangent square x? You know, the easy one would be cotangent square x times 1 over cosecant square x, which is equal to cotangent square x times 1 over cosecant square x. So you see how I factor out cotangent square x from the numerator and get 1 over cosecant square x? So, doing that, I notice I have a identity that I can apply. So I'm going to apply the reciprocal identity, which is 1 over cosecant x equal sine x. So cotangent square x will stay the same, but now it's going to be multiplying to sine square x. So all I did was just rewrote this one into this. Alright, we're still not the same as cosine square x. So what I'm going to do, I'm going to make more room. So I'm going to erase everything else. So then we're going to continue from cotangent square x times sine square x. Alright. Now, what I would analyze is, or ask myself, is there a relationship between cotangent square x and sine square x? Yes, there is. I can apply quotient identity. So for cotangent x, that equals to sine x over, I'm thinking about tangent, but we're doing cotangent. It's cosine x over sine x. So since we have cotangent square x, it will be cosine square x over sine square x times sine square x. Then a fraction times a whole number, same as before, which is a multiply to the numerator. So it's going to be cosine square x sine square x over sine square x. Now looking at that, hey, there's a common factor that I can divide into 1 because it has the sine square x on the numerator, sine square x on the denominator. So I can divide into 1, and that will equal to what's left, which is cosine square x over 1, which will simplify to cosine square x, which is the same as the original. So we did the left side, so which is cosine square x, and it is equal to the original answer that was given from the beginning. So once you do that, that's pretty much it. And as higher math classes would do, this is what they would write, saying that this is the end of their work, QED. So we just verify the left side by doing all the simplifying by using the reciprocal quotient identities, the Pythagorean identities, factoring out, and then converting into sine and cosine. So once you simplify and verify that the left side is equal to the right side, you're done. Alright, in our second example, we have secant square x times cotangent square x minus 1 equal to cotangent square x. Now, again, we have a better sense of direction where we should go towards, which is cotangent square x. So we always work out the complicated side, the complex one, which is the left side. Now, here, I'm not sure what to use for secant square x, cotangent square x. So the best one I would think of is to rewrite into sine and cosine. So for secant square x, I will use the reciprocal identity. So secant x equal 1 over cosine x. And then I would also apply the quotient identity for the cotangent. So cotangent x is equal to cosine of x over sine of x. So secant square x will be 1 over cosine square x, and it's multiplying, so I'm going to put parenthesis. For cotangent square x, it will be cosine square x over sine square x, and then the minus 1. Next, I have two fractions and multiply, so I'm going to multiply straight across. 1 times cosine square x will be cosine square x over cosine square x times sine square x will be cosine square x sine square x, and then the minus 1. So taking a closer look at it, I noticed that there's a common factor, and again, common factor because at the bottom it's multiplying. So now I know that I can simplify, because when I said there's a common factor, which is cosine square x in the numerator and our denominator, I'm going to divide both of them into 1. So when I divide, I'm going to have 1 in the numerator over sine square x and then minus 1. So continuing from 1 over sine square x, I'm going to apply another identity, the reciprocal identity, which is 1 over sine x is cosecant x. So for this part, 1 over sine square x, it will be cosecant square x minus 1. And then I notice this looks vaguely familiar. Cosine square x minus 1. If I recall, that's part of the Pythagorean identity. Which is cotangent square x plus 1 equal cosecant square x. And then if I want to get the 1 to be with cosecant square x, I would subtract 1 on both sides. And then we're going to have cotangent square x equal to cosecant square x minus 1. So hey, cosecant square x minus 1 will equal to cotangent square x. So what do you know? The left side does equal to the right side. So cotangent square x equal to the original answer, which is cotangent square x. So once I finish verifying that the left side, which is secant square x cotangent square x minus 1, does indeed equal to cotangent square x, that means you're pretty much done. So Q, E, D. So in review, I list out all the identities that we use here: reciprocal quotient, multiply fractions, and then apply reciprocal identity again, and then apply Pythagorean identity. Now this example used a lot of the identities, and as we progress to 5.2, we're going to talk about how we're going to simplify by combined fraction, simplify by eliminating fraction, simplify by factoring. Now one of the 4 topics that we used today was we wrote sine secant square x and cotangent square x into terms of sine and cosine. So that's an example of what we did from 5.1. And again, we're going to continue using those 4, or a combination of those 4 topics that was covered in 5.1 and 5.2.